Howdy, my name is Aidan Yourk. This is an assignment for Dr. Kate Davis's ECEN 340 class at Texas A&M University, fall 2022, and for this assignment I have chosen the topic of rotational systems. A rotational system is, in its most basic form, a machine made up of two parts, a rotor and a stator, where the rotor rotates and the stator is stationary. This machine takes advantage of electromagnets, and sometimes permanent magnets, to manipulate magnetic fields in order to induce a current in the stator by rotating the rotor, or produce rotational motion in the rotor by running a current through the stator. Because of this, rotational systems are integral to the conversion of electricity and mechanical energy. Rotational systems can be classified into motors and generators. The conversion of electrical energy into mechanical energy is done by motors, and the conversion of mechanical energy into electrical energy is done by generators. It is important to note, however, that the two are not exclusive in their functions, and that a motor can function as a generator, and a generator can function as a motor, though they aren't often operated as such. Generators can be found in any system that produces electricity, from wind turbines to nuclear power plants, while motors can be found in fans, clocks, air conditioners, vacuums, and more. Depending on their application, rotational systems can vary in design, starting with synchronous machines. These types of rotational systems can use a permanent magnet or a DC-powered electromagnet as the rotor, and 3 to 6 coil windings on the stator. Synchronous motors are supplied by three-phase power on those coil windings in 120-degree intervals, such that the coils in the stator produce magnetic fields that spin the rotor as the magnitude and direction of the magnetic fields change with the phases. The downside of these motors is that on a large scale, they cannot be started from rest. Something must overcome the inertia of the rotor before it can get going. In addition to that, the speed of a synchronous motor is tied to the frequency of the three-phase power supplying it, so the speed of the motor isn't very easy to change. Synchronous generators work much the same way, just in reverse. As the force turns the rotor, the magnetic field produced by the rotor induces a current through the coils as it passes by them, generating a three-phase current. Synchronized generators are sometimes referred to as alternators, and can be found in things like cars, for example. Synchronous machines function better as generators than motors, so most synchronous machines are often used as generators. This isn't to say that there aren't any synchronized motors, as many stepper motors are synchronized motors. In all synchronous machines, the speed of the rotor is in sync with the frequency of the three-phase current, hence the name. The same cannot be said for induction or asynchronous machines. These are similar in design to synchronous machines, the key difference being that the rotor is not magnetized permanently or by an external power source. Instead, the rotor is replaced by some closed loop of wire, the shape of which can differ. As the three-phase current induces a rotating magnetic field around the stator, a current is induced in the rotor, which in turn produces a magnetic field that works to counteract the magnetic field applied by the stator, causing the rotor to turn. The speed of the rotor will always be slower than the speed of the magnetic field rotating around the stator, because if the speed of the rotor was ever equal to the speed of the rotating magnetic field, there would be no current induced in the rotor, and therefore no magnetic field moving the rotor. Due to their ability to start from rest, induction motors are used in almost every electronic device which needs some kind of rotational motion, like fans or pumps. Asynchronous generators apply this in reverse, by spinning the rotor itself, which induces a lagging current through the stator coils as it passes by them. The downside here is that the rotor coil must be at least somewhat magnetized for the generator to start up, meaning that the rotator coil must be connected to an external power source to start up, or contain some residual magnetization. The biggest application for these types of generators is in wind turbines, which can be connected directly to the power grid as a way to induce a magnetic field in the rotor when the turbine is spun from rest. All induction machines do not match the frequency of the three-phase current applied or produced. In the case of induction motors, the rotor is slower than the frequency of the three-phase current applied, and in the case of induction generators, the rotor is faster than the frequency of the three-phase current produced. The final type of rotational system is the DC machine, which differs from the first two in a few ways. The most obvious is that while the other two machines take in or output AC power, DC machines produce or are powered by DC power, hence the name. Second, DC machines are connected to the output or source via the rotor, which is composed of a loop or coil of wire. In addition to this, the stator is made up of permanent magnets. The current induced in the wire will change every half turn of the rotor, however, so in order to keep the direction of the current constant, a commutator, also known as the brushes on a typical DC motor, is used. In DC motors, The current supplying the rotor causes the torque applied to the rotor by the stator to be constant in either the clockwise or counterclockwise direction, due to the commutator keeping the direction of current flow constant in the wire. This works in reverse for DC motors, which induces an alternating current in the wire as the rotor turns, which is outputted as direct current by the commutator. The DC machines themselves can take a few different forms depending on the application, like brushless DC motors, for example, but they still incorporate commutators into their designs so that the AC produced as a result of induction produces a direct current. DC motors were the first motors to be widely used and are still used in many battery-operated electronics like power tools or electric cars.